Hello everyone. So first thing we have to do for this triangle is to find the area. And in order to find the area, we need the base, which we have, 15, and we need the height, which we don't have. So let's use the Pythagorean theorem to find that. We know the length of the hypotenuse, so we're going to write 17 squared minus the length of one of the legs, 15 squared, and that will equal the height, which is the other leg, squared. Hi everyone. So for the first part of this question, we have to find the area of this triangle. And the formula for the area of a triangle is base times height divided by 2. Now, we know the length of one of the legs of this triangle, so we can use that as the base, but we don't know the other one, which would be the height. So we need to use the Pythagorean theorem to find the value of h. So because we know the value of the hypotenuse, 17, we can write the Pythagorean theorem in this format. 17 squared minus 15 squared is equal to the height squared. So 17 squared is 289, 15 squared is 225, and then we're looking for h squared. So if you subtract these, you will end up with 64 equal to h squared. Take the square root of both sides, and you will find that the height is equal to 8. So we can write that in here. Height is equal to 8. Great, now we have all the measurements that we need in order to compute the area. So I'm just going to plug that in here. So the base, 15, the height is 8, and we divide by 2, which gives us 60 centimeters squared. That's the area of the triangle. Okay, great. So we found the answer to the first part of the question. Now the second part of the question says, what is the distance from the vertex of the right angle to the hypotenuse? So it's asking us to take this vertex here, where the legs meet at the right angle, and find the shortest distance to the hypotenuse. The way that's going to work is the shortest distance is going to be perpendicular to the hypotenuse, and it will hit the hypotenuse at a right angle, just like that. So how can I use the things that I already know about this triangle in order to find this length here? Do I have everything I need? Well, actually I do. So the way I'm going to look at this to make it easier for myself to understand is I'm going to take this triangle and I'm going to flip it. Just going to take it and flip it like that so that it's sitting on a different, so that it's actually sitting on the hypotenuse. Now let's relabel it. We had the hypotenuse, which measured 17. We had the long leg, which was 15, and then we found out that this side here measured 8. And what we're looking for is this length here. So in the context of area, what does that look like to you? Well, naturally, that seems to be the height of this triangle. Now, if we take the formula for area, which is base times height divided by 2, what can we plug in? We know that the area is 60. That hasn't changed. We just figured that out. We just flipped the triangle over, but it hasn't changed in size or anything. Base, well, we can use this as the base now. 17 is our base. The height is what we don't know, and we divide by 2. So we only have one unknown variable here, so we can easily find out what h is. So I'm going to multiply both sides by 2, and I'll get 120 is equal to 17 times h, and I divide both sides by 17, and I will find that h is equal to 7.058 7.88, which I'm going to round to 7.06. And that is the length of this, that is the length of the point of the right angle to the hypotenuse.